All right. So again, we're looking at linear quadratic systems. So just to kind of reiterate what, like what when we talk about a system, like what is a system? Well, a system is just like one line and one parabola. Okay. Now in the Desmos activity, there were a couple of examples where you had two parabolas, which is totally cool. Graphically, no big deal. But we're not going to really look at that kind of a situation. We're just going to look at lines and parabolas or linear functions and quadratic functions. Okay. So clearly we have these three kind of situations. Okay. So a quadratic and a line can cross at 2 points, right? So we call that, it has two solutions or 2 points of intersection. Okay. Now this line has a special name. So if, again, the names, the only one that you have to remember is a tangent, but this here we call this a secant. So if you're going to take math next year, and I'm assuming most of you are, you will become familiar with this term and this kind of image when you start doing calculus, which is going to be exciting. All right. So a line in a parabola can cross at 2 points. They can cross at 1 point. Okay. And this one is called a tangent. Now you've seen tangent before because tangent is conveniently also a trig ratio. Okay. And that is 1 point of intersection. So if you look here, like, so we can kind of have two like, I mean, I have this like the line that kind of like, it's like it skims the quadratic, you know what I'm saying? So like this would be the 1 point that it crosses, that it touches, okay? Or like, I have a point here and it crosses there at 1 point, okay? Generally, we don't consider like, so if you see, have a vertical line. If I have a vertical line, that works, right? It crosses the quadratic at 1 point. The problem with a vertical line is that its slope is undefined. So generally, like it's still a tangent, but you'll see when you take calculus that generally we kind of don't like to use a vertical line as a tangent line because the slope is undefined. And the last situation here is just, right, I have a parabola, and then we have this other line floating in space, and these two functions will never meet. They'll have no point of intersection. They have no solution, all right? So what we're going to do is we're going to go over how we solve a system, a quadratic linear system, algebraically for each of these situations. All right. So I'm just going to go to another screen for myself. All right. So this is just this is a site that I've used before. It's called Grassable Math. So like I'm just using it as a notepad, but it also has some interactive math things. Or not math things, but mathematical capabilities. Okay, so we're going to look at an example of where I solve a system, and this is going to give me 2 points of intersection. All right. So I'll give you a sec just to write that down, and then I'm going to solve the question in this space. Okay, so again, we have f of x, g of x. This one is a quadratic. This one is linear. All right. So generally, what we're going to do when we have to, solve a system, right? Like, what does the term solve? What does solve mean? Well, we want to find where the functions are equal. All right. Now, when we say find, like, where are they equal? They're equal at a point, right? Or 2 points. And generally, how do we do that? Well, we make them equal to each other. And bring everything to one side and solve the quadratic equation. Okay. So again, what I'm going to do with these two functions, f of x and g of x, is I'm going to make them equal. All right. And that makes, when you think about it, that makes sense, because if I'm going to find where the functions are equal, and we know that when we think about it graphically, it's where the lines, or the line will cross the parabola or hit the parabola, then it makes sense algebraically for me to make the two functions equal and then see what happens. All right. So yeah, so I'm gonna make f of x equal to g of x. Okay. Now I'm just gonna type in my equation, and I'm just gonna use this technology to solve it. Okay. So I'm going to insert expression. So 1/2 squared plus 3x squared plus 3x minus 4 equals 1/2 plus 3. Okay, and then let me bring that down. Okay. So that's what I've done here. Okay, so I just made them equal. I have f of x on the left, g of x on the right. So now what we want to do in this situation, let me get my draw, right? We're going to move everything to one side. All right. So, oops. So now what am I going to do? So notice how this is a squared term. So the x squared term is here. I'm going to move everything here onto the other side. Okay. So what I get, so like this plus 3, when I can move across, it becomes a minus 3, right? This whole thing here, I'm just going to move. Gosh, oh man, I screwed that one up. 1 second. There we go. Okay. So I move the plus 3 across, it becomes minus 3. I move the 1/2 x across, and it becomes a minus, right? And then now, like, oops, like this whole thing, oh gosh, like this we can combine, right? And then this we can do, right? I don't know, what the heck? That's not going to work. Cool. Let's see if try to double tap. Oh, oh god, oh god, oh god. What the heck happened here? Sorry. So that's cool. Oh man. Let me just I'm gonna solve this one by hand right now because this didn't happen to me before. So again, here I have 3 minus a half, which will be, so that will be 6x minus x over 2, right? Minus 7 equals 0. So I'll have 1/2 x squared plus, this is going to be 5 over 2x minus 7 equals 0. All right. Let me just double check I didn't screw that up. Right, because that'll be 2, 6. Yeah, no, that's good. All right. So now we're left with this. Okay, so now this equation here, this is a quadratic, right, equation. Okay, it's equal to 0. So how do we solve it? Well, we solve it by either, right, we can factor, or we can use the quadratic formula. Okay. So generally, when we see fractions, we'll go right to the quadratic formula. So now on here, let me see if this will work. Well, this, no. So I'm going to retype this here just to solve this a little bit more quickly. So if I retype my expression, so 1/2 squared plus 5x over 2 minus 7 equals 0. Okay. Then I'm just going to move that down. Okay. I just recopied it, but I want it in this form because what I'm going to do is I'm going to use the quadratic formula. What the heck? Why is it not letting me do this? One sec. This is why I never use technology, right? Let's try it out. It's weird. Well, I guess I'll have to do it the slow way. So, one sec. Let me just see if it works if I do this. No, that doesn't work. Ah, well. So let's do it the slow way. All right. So I'm just going to write down our values here. So I get A is 1/2, B is 5/2, and C is -7. Okay. Oops, I forgot to input the numbers. So this is going to be minus 5/2 plus or minus some square root. So 5/2 squared minus 4 times a half times -7. All over 2 times, oh, I got a bracket there. 2 times a half, right? Yeah. And then now I'm going to have, okay, so 5/2 squared is going to be 25/4 minus, so this whole thing is going to be, so minus times a minus is going to be a plus. It's going to be plus 28/2. And then notice this whole thing is divided by 2 times a half, which is just divided by 1. So I'm going to now just have, like, dividing anything by 1 is actually good because I'm only going to be left with the numerator. So I'm going to have x equals minus 5/2 plus or minus square root. So this here, so okay, so 25/4. Can I simplify that one? Well, let's just wait. So 25/4 plus 28/2 is 14. Plus or minus. And this one, so I'll have to get a common denominator, which is going to be 4. So it's going to be 25 plus 56/4. So then x equals -5/2 plus or minus square root. So that's going to be 81/4. And then now, oh, I'm so happy, guys. This is great because 81 and 4 are perfect squares. Wow. All that work, I was getting stressed out. So -5/2 plus or minus. So this just is plus or minus 9/2. So that means I'm going to have one answer. So x is going to be -5/2 plus 9/2. And I'm going to have another answer where x is -5/2 minus 9/2. Okay. And then I'm just going to figure out what this is. So this is going to be -5 plus 9/2, which is just going to be 2. And this is going to be -5 minus 9/2, which is going to be -14/2, which is -7. All right. So now at this step, this is, remember when we factored and stuff, you find zeros or whatever, like here we're not done because we want to solve the system. So that means we need to find the points, okay? So, right, if x equals 2 and x equals -7, we need to find the y coordinates. All right. So what that means is that I have to take x is 2 and x is -7 and plug it into either f of x or g of x. Now, it doesn't matter which one you plug it into. All right. So we will plug x equals 2 and x equals -7 into either f of x or g of x. Okay, because we've already established that these two functions are equal to each other when x is equal to 2 and x is equal to -7. So it doesn't matter which one I pick to get the y value. So if we look up quickly, g of x, I mean, it's a smaller one, so let's just use g of x. Okay, so I have g of x equals 1/2 x plus 3, right? I think that's what it is. Yeah. Okay, so when x equals 2, I'm going to get g of 2, which is going to be 1/2 times 2 plus 3, which is just going to be 2 over 2 plus 3, which is just going to be 1 plus 3, which is going to be 4. Okay? So therefore, 2 and 4 is one solution. And then when x equals -7, just do the same thing. G of -7 is going to be 1/2 times -7 plus 3, which is going to be -7 over 2 plus 3. So this one I just need to find the common denominator, which is going to be 2. So this has this if this needs to be 2, then that's got to be times 2. So -7 plus 6 over 2 is just going to be -1 over 2. So -7 and -1/2 is the other solution. All right. So those are my two answers. So again, a little bit of work, but the algebra that we're doing isn't necessarily, it's not something that you haven't done before. Okay, the only new thing compared from, the jump from 10 to 11 is that we're looking at quadratic and linear systems. All right. So what we'll do, why don't we just take a little break right now. We have a few more examples to go through. All right. So